Hi, everyone. I hope you're doing great today. We're going to create a program with profile using curves and a variety of approaches for that. So we're going to start right away with this part. I need to set up an alignment first, because I haven't done that yet. So I'm going to turn off the simulation here. And I'm going to delete the curve that I have already so we can start from scratch. So you'll notice this is a symmetric part. So for the purposes of mirroring things and getting everything centered, it would be beneficial if we can set the alignment similar to where the CAD origin is already. You know, we could set our origin on this left hole, but it's going to make our life easier if we set everything to the midpoint. So I'll start by adding my alignment features, and the quickest way to do this is open up our alignment before I make the features. So you'll notice in version 2024, they rearranged this window a little bit. So you have to hit this little icon to create a new alignment. And I'm going to add a plane. So I'll just extract this plane. Later, I can add in a polyline on there. So you notice right away it pops in for the spatial rotation and the Z origin. Then we have, we need to create a line going through these two circles for the planar rotation. So initially I thought this would be quicker, but probably not. So I'll come back to that after I construct some things. So let's go ahead and, all right, sorry about that. I did not start sharing my screen. I apologize about that. I clicked on the wrong thing here. So I'm going to share screen. We're going to do this screen. All right. Now hopefully you can see it. All right, so I was setting up the base alignment, and in here, I went to create a base alignment, and I extracted this plane. So it pops in right there for the rotation in space and the Z origin. But since I need to construct a midpoint from these two circles, I can't create that construction on the fly. So I'm going to go to Features, and we're going to add in the circles right here. Yeah, there's a difference between programming every day on your own and then programming while other people are watching. So hopefully next time I'll remember to share my screen right away. So we got the two circles. Now we'll create a line right through those. I'm moving through this pretty quickly because I want to focus in on the profile stuff. So options recall between these two. And then we're also going to put in a symmetry. So that would be the midpoint between the two circles. And then this plane, I'm going to put in a polyline. Just going to scan along the edges. I'll click reset because I want to have it go in a little farther. And it's a pretty good speed. Make sure we have enough points. Okay. So that'll be our plane on the top. And all this stuff is our alignment. Okay, so we'll go back into our base alignment. We're going to change it. And our planar rotation comes off of the 3D line. X and Y is coming off of the symmetry. And there we have it. And like I said, on a part like this, if you have features on either side that need to be mirrored, either left to right or front to back, it makes a lot of sense to have your origin right in the middle, even if your datums are not called out that way, for programming purposes, it makes it really quick. All right. And you'll notice I haven't saved this yet, so I'm going to save this as a separate copy. I'll just save it in the downloads for now. Save it in a different place later. We're going to call this the port body. Okay, so everything is located. We'll put in a clearance plane from the model. Another thing I like to do, if I can, is put any fixturing in the model. So here's another little trick. You can open up any fixturing models that you have or blocks. I'm just going to use a 246 block. And then we're going to position it to simulate how we would have it set up physically. So you would go to CAD, modify CAD entities, and then positioning. Then you select the fixturing model so it turns pink. And first I'm going to rotate it around X, 90 degrees. And we'll rotate around Z, 90 degrees. Then I need to move it down in the Z, -1 inch. Maybe click apply a bunch of times. And then to get it exactly flush, there's two ways of doing this. The first way is to just get a distance between the two surfaces. So plane to plane. And then we can copy this value, Control C. And then we go back to the same window. And we do positioning. Select the model. And we want to go Control V, paste, apply. So now it's the correct distance. The second way of doing it is you can do positioning with a target point and click position, and you put a point on one model and a point on the other, and it glues them together. And then you click apply. So that's actually quicker in this case. Then we can just shift the model around in the X direction. So that helps a lot when you're programming, just to make sure you're not going to hit something. All right, so now we can get into the meat of this, which is the profile. So you'll notice I have this yellow line, which is a section line on the model. And I'm going to remove that line first. We're going to add it in again. So anytime you're creating a curve, you typically need to section the model. So we're going to go to CAD, creating features, and then section. And you'll see this transparent green plane, which you can resize it from the corners. You're basically slicing the model wherever that plane is intersecting. And you can control the direction of the plane with these normal vector options. So if you ever remember trigonometry from high school, you have the different ratios of the sides of the triangle. That's kind of what we're dealing with here, is the ratio of the angle. And most of the time you can just do zeros in two of the boxes and one in the other box, unless you want a specific unusual angle. So in this case, with a 1 in the Z, it's a plane facing Z. So if I want a plane in facing Y, I'll just do 0, 1, 0. So you get that, how it just changes the direction. So if I put 1 and 0.5, it gives me an angle that's like that. But most of the time, if you need a specific angle, you would create a secondary alignment and use this alignment. Okay, so we want a plane in the Z, and then we can control how far down from the Z origin. And I want to go minus 60 thousandths. All right, so I'm just going to read quick any of the questions on the chat. About positioning CAD models by target points. Does the order you place points matter? Does the first point go on the model to be moved, and the second one on the surface to move it to? Good question. We'll get to that after I finish this. So you've got your plane where you want it to be. Then you click section. And it gives you a line. Let's say you don't like where it's sectioned. You can move it again and hit section again. And if you want to erase those yellow lines, go to CAD, modification, and then delete free lines and points. Just keep doing it till you need, or till you get the right spot. So I just wanted to be above this radius. All right, so we got our section line. My goal is to measure the outside profile. So now we go to creation, turn off the solid view, and then click one of the edges. And then in the newer versions of Calypso, you have this option for contour completion, which will select all the edges that are touching. If you don't have that option, you just use the control key and click, click, click all along. Make sure you do it in order. Now that they're all selected, I can see the entities are listed up here. Then I put in how many points I want. Now you can adjust the number of points later, but important thing to remember, if you do only 100 points and then you want to increase the number of points, it's not going to increase the resolution, or it's not going to make it better quality. In other words, if you have a contour that has some tight corners, a lot of detail, make sure you put in lots of points. Otherwise, if you want to later increase the number of nominal points, it's going to be kind of jagged. So just go on the high side. This contour is not there's not many tight corners. So I'll just do 1,000. And then click curve. So you have the option of a 2D curve or a 3D curve. If the sidewalls are straight or perpendicular to the plane, we can do a 2D curve. If the sidewalls are drafted or you have an unusual shape, you need a 3D curve because it will adjust the vectors for that slope. Okay, so now we have our 2D curve. Occasionally, the vectors will be flipped, and you wouldn't be able to measure it that way. So if you don't know what a vector is basically the direction the probe is coming at towards the surface. And here the little yellow arrows should always be pointing away from the model. So right up here, you can reverse it. So now that we have our curve, let's pause on this. We're going to jump back to Jeff's question about positioning models. So I'm going to bring in another block. And we're going to position that block. Let's just move it over a little bit. And let's say we want to make it touch on this side. So he's asking, does it matter the order you place the points? So in this window, the positioning window, it always has one model or one body of models that are active at a certain time. So when I click apply, only this one is moving. So this one is not going to move at all. So in your CAD view, there's actually separate bodies. There's separate pieces. And if you look in hierarchy, these are different bodies. So I could select this one or this one or this one. Keep in mind, if you do the CAD healing, it welds everything together as one body and you can't move things around anymore. You basically have to delete surfaces. So that's why sometimes I skip the healing, because you don't always need it. Anyways, so with the positioning, the order, I don't think it really matters because it's only going to move the active body. So if I do position again, and if I try this one first and this one second, let's see. Actually, I take that back. See, this is something I haven't experimented with. So it looks like it's moving the first item and the second, or the second one stays in position. Interesting. I'm glad you asked that question. So then your other question is, does the first point go on the model to be moved and the second on the surface to move it to? So yeah, that's basically what we just observed. Now let's do a little experiment. If I do it the opposite way, go -2, and we're going to select this one, and we're going to do positioning. So yeah, the first one you pick is the one that's going to move. Now what happens if I have the other one selected? Let's see here. So it doesn't matter which one is selected. First point is the model to be moved or the body to be moved. And then the second point is where it's going. Very cool. So now I need to get rid of that. So if I go edit body, select this one, I can delete it. And then we can go back here. We want to move this block up. So go position, point here, and point up here. And apply. Alrighty. So we got our block in place. We created a curve. Wow, time is going by. Let's see if we can dive into the details of curves. So 2D and 3D curves are very similar. Like I said, on a 3D curve, the vectors are not all going to be on a parallel plane or horizontal plane. And think of this as, most of you have done one of those dot to dot things on pencil and paper and has the numbers for each dot, and then you just connect the dots. And some of them have lots of dots, so you can really have a interesting shape. That's really what is going on here. A curve is a dot to dot game where each of the dots is a nominal point. So if we look in here at the curve, we'll just turn on the curve only. For the purpose of graphics savings, Calypso has it only show a sampling of the nominal points. We can right click and go extended and show all nominal points right here. And then this green one is where it starts. And you can also right click and show the point numbers. So this is our dot to dot game. So we have number 1 and number 1000 because they start and end at the same place. And then it goes 2, 3, 4. So the probe is going to follow there. If you initially created the curve with not enough points, it's going to be choppy. Let me just show you. CAD, creating features. I'm going to show the model again. I'm going to go hide surfaces, pick this, contour completion. Let's say we only did 50 points. So now here you have your points scattered. And let's say I changed my mind. I wanted to have more points. So then I'll show you how to do this soon. But let's say I wanted to have 1,000 points or 2,000 points. So now I'm going to view from the top. Turn on the CAD quality to be high. So see how this choppy curve is not the same as the other curve, which follows the model more closely. So this is the better one, and then this is the choppy one. It's cutting off the model. So always make sure you have enough points, but don't get too carried away because curves do take a lot of resources. All right, now the next step when I'm setting up a curve, I have the initial 1,000 points, but let's say I want to have a consistent point spacing for all the curves that I'm making. I can go to this middle dropdown, nominal geometry manipulations, and then modify nominals. And we're going to set based on a step width or point spacing. Let's say we'll do every 10 thousandths. And you'll notice in our list of points here, now we don't have 1,000, we have 991. Okay, so those are our nominal points, but there's also the measured points. And this is where it gets a little confusing because you have two different point spacings. So just remember, this is our dot-to-dot game. We have those nominal points like beads on a string. But in the strategy, you have the segment, which is the scan path. And here's a different step width. Now, Zeiss recommends you use at least twice as many measured points as nominal points. So 2 to 3 times. So we would put 5 thousandths or even less. Or you can go by number of points. You could do 2,000 points or 3,000. The reason for that is because the probe is going to scan measured points in between the nominal points to average it out. You wouldn't ever want less than the number of nominal points you have. Your speed is going to depend on how many tight corners you have. If we have a tight inside radius, we would reduce the speed for that. And for a part like this, where everything's pretty broad and open, we can go a little faster. Also very important, the endpoint, the start and end point needs to match the number of points you have. Because if this endpoint, let's say if that is at 800, and I execute this in the simulation, it may not show up in a simulation, but let me just show you. Just hang on a second. Hide the point numbers. You notice the yellow line, it goes around, but then it ends over here. And that's right now it's not showing any problems, but on a measured part, you're going to have problems because it's going to try to calculate the profile, but now it's dangling. There's missing points. So make sure in your segment, you're going to have as many points as you have total. And to solve that problem, you can just click this checkbox, segment from all nominal points. That's assuming you have just one segment. Some curves have more than one, but if you just have one continuous curve, just click that box. Also really helpful is the pre and post travel. So the probe will get a head start before it's going to measure And usually you want 3 times your point spacing, so at least 30 thousandths. Depends on how flat that surface is. Those are the main settings. And then as far as evaluation, you have to be careful with the outlier elimination because Calypso might take out data that you're trying to see form variation. So Zeiss Cookbook recommends you just do the filter. And notice someone asked about that. What do you think about the Zeiss Cookbook? Ferdy asked that. And I do have the Zeiss Cookbook. It's a good reference you can use for looking at what are the recommended speeds and stuff. It's pretty conservative. It's more on the slow side. And even in the cookbook, it says this is just a reference or a good starting point. It's not like you must do or you won't have accurate results if you go against the cookbook. So use it as a good reference. And I would say you can go a little bit faster than the recommended speeds. But it is really helpful when you're trying to set a standard or set a guideline. I did end up creating a really fancy spreadsheet that calculates all my speeds and stuff based on the cookbook. And I was going to offer that to people. But then I contacted Zeiss and they said, no, you can't do that because it's copyrighted and so on. So just buy your own cookbook and you'll get a feel for what makes sense on the speeds. If you're not sure, just go slower. Generally, when you're doing holes, when you're measuring a hole scan, which is very common, a good rule of thumb for the speed is the diameter. That's just what I use as a baseline, and then I adjust from there. So majority of holes you're going to be measuring are less than an inch in diameter. And it also depends on the sensor you're using. The passive sensors are going to need to go slower than the active sensors. So this one is a 0.86 diameter. If I'm using a passive sensor, I would probably go no more than a ½ inch per second. But if it's an active sensor like VAST XT, we could go up to an inch probably per second. Another thing to watch out for, if your hole diameter is pretty small, like 1/4 inch or less, just make sure it has a good overlap for the angle range. But those are some things you would pick up in the cookbook. And it helps you if you're not familiar with the recommended settings. All right, having some fun. So I'm probably going to have to save the 3D curves and other profile type of evaluations for next time. We can take this one and pick up where we left off. But if we want to report just the profile of this, we can go form a location, line profile, pick that curve. And then we go, and if we're doing it just to the base alignment, that's our datums. We could use other datums. And next time, I think we'll do kind of a part B of this, and we'll do explanation of the different types of output for profile, because you can do a variety. For now, you'll notice that the default is one result. It's going to tell you 2 times the worst deviation from nominal. All right, I'm sure you guys also have a busy day to get to, and I do too. So let's see, we've got any other questions? Looks like not too many. If you have any other questions, feel free to email me, steven@learncmm.com. Otherwise, we'll see you in 2 weeks because next week I won't be available. All right, so thank you very much and have a great day.